So our next topic is decision tree. Basically, here what we are trying to, this is a little bit different from other approach. So here it is a basically rule based approach. Now in decision tree, here the discussion scope is only Gini index based decision tree in classification and standard deviation change based the decision tree in case of regression. So and these things will be implemented in the upcoming videos also. Not in the Excel, but it will be implemented in the Python. So what is decision tree? Decision tree is nothing but you are trying to represent entire decision making process with the help of a tree. So let's say if I have this kind of situation, I have a data set which is highly means kind of a specific, or let's say when your data is a little bit size is either medium or low, you can implement decision tree. So let's say I have two cases or two features where I'm just trying to predict whether I am going to play or not. So here is a sun outlook of the day. So I'm adding another feature with it. It will be better. So let's say I have outlook. Maybe windy, because this example is very classic example. Every book they use this same uh, example for understanding the decision tree and then my decision to play or not. So let's say if my outlook is sunny and windy, then I will play yes. If it is cloudless or gloomy, windy, no. Then it may be rain, no. Still I'm not playing, no. Gloomy, but no. Okay, and windy is no. Then I will play yes. So let's say this is a kind of a problem for me. So these kind of problems very easily used for decision with the help of decision tree. So now just check this is the binary variable or categorical variable which I wants to predict. So basically this is a classification problem with the help of two of my feature, that is outlook and another windy or not. So in this case, basically the concept is that we try to find out a particular feature which has means the based on the impurity only we try to select the root node. So in that case, you have to consider, let's say this impurity can be measured with the help of the Gini index. Now if I can write the expression for Gini index, that is sum of pi. So probability of particular instance, the 1 minus sum of probability of instance, that is nothing but the Gini. So this Gini indicates the impurity. And let's say if I wants to calculate that, first of all, you have to calculate, let's say impurity value for outlook and windy, then you have to just represent the entire decision making process. So how to calculate this Gini index for outlook? Now let's say under outlook, how many cases are there? Sunny, gloomy, rainy, and again gloomy. So if I just take sunny, so if I calculate the Gini for sunny, so this will give you 1 minus, now you have two cases, whether you are going for play or not. So but in case here you just check under sunny, only one case is there. So total case, so how many success case are there? One success case, so 1 by 1 total case. minus, because there is no specific case related to no or failure case, so I will have to put 0, and because total case is 1, this. So this is nothing but the probability of how many cases you are observing that success is there, and this is the nothing but the probability how many cases you are observing the failure. So because under Sunny only one case is available, so I have to consider it as a 1. So definitely my Gini index for Sunny is 1 minus this is 1, so 0. Similarly, I can calculate the Gini for, let's say, Gloomy. So I'm just writing. So 1 minus, now under Gloomy you just check, I have two cases, this, so I'm just using another pen, so this case and this case. So definitely how many cases it is, we can observe that success and failure, one case is success, one case is failure. So I have to write 1 by 2 1 by 2 square minus again one case of failure divided by 2. So again 1 minus, this is 1 by 4 minus 1 by 4, that is 1 minus half, that is half. So this is the Gini value for Gloomy. Similarly for the Rain also, it is 0 because 1 minus, it is only having one case, that is no failure case. So definitely 1 minus 0 by 1 square minus 1 by 1 square, so that is 0. Now we have to calculate, so this is the simple concept of Gini calculation for every level of particular feature. So let's say if I calculate, I need to calculate for how many Gini for a particular outlook, particular feature or outlook. So G outlook will be, so you have to just calculate how many cases your particular level is appearing. So in this case, let's say for my Sunny appears only one time. So how many cases are there? So how many? 1, 2, 3, 4 out of 1 by 4. So if I just straight away I can add this value, 0 plus half plus 0. Okay. And every time I have to just multiply how many times that particular case is appearing. So out of 1, 2, 3, 4, 4 cases Sunny appears only once, so 1 by 4. So you have to just multiply 1 by 4 with this. Then you have to multiply, let's say the second case is Gloomy, how many times Gloomy appears? So twice, so 2 by 4. And for again for Rainy it appears once, so 1 by 4. So definitely the value is, if I just cancel out this 2, so this 2, so it is 1 by 4. Now similarly I can calculate the Gini value for Windy, and when you are going for a split, let's say you want to decide from where you are actually which node is generating that particular first node. So there also you have to just compare the value of delta G or change in the delta G. So that can be calculated by total Gini minus particular Gini from particular feature. So this total Gini can be calculated from this your feature of play. So let's say I'm showing how to calculate. So let's keep this value 1 by 4 for Gini O. So here first of all I have to identify how many cases are yes, how many cases are no. So let's say here I have 2 cases yes, 2 cases no. So definitely G total equal to 1 minus 2 by 4 square minus 2 by 4 square. So this is nothing but 1 minus 1 by 2 square minus 1 by 2 square. So again it is 1 minus 1 by 4 minus 1 by 4, that is half. So if I calculate this delta G, so definitely it will be half minus half equal to 0. And similarly, I can calculate this change in the Gini index for another variable, that windy, and then you have to just compare. So this delta G for outlook and delta G for windy, and then you simply just create a decision tree. So definitely if I just observe this case, so here I have only 2 instances. So let's say I'm just putting the value over here. So here half, so already I have calculated this half. So here also this is kind of a half minus half, 0. So in this case I can randomly pick any value or any feature for starting the node. Now luckily in this case both values are same, but let's say if a value for this delta G value becomes a particular value, maybe 0.3 or 0.02, in that case the delta GO has a lowest Gini. So I can consider this delta GW for a criteria to actually split the node. So in that case what will happen? First I will consider, okay, windy, then I will split it either yes or no. Then again under this I can consider, let's say, outlook. Let's say if it is sunny, then under sunny you straight away you can come to the decision of play yes, yes play. Or if I am just considering again under yes, so another okay, just a misrepresentation happens here. So I can just write 2 things over here. Here yes, here no, then here I'm just putting in my outlook. So under yes, so 2 things are there, sunny, this is gloomy. So in that case the last thing will be play yes, and this is play no. Again here also the outlook under rainy and gloomy. Here also I can write okay, outlook is yes, okay, outlook sunny, gloomy, yes, so yes no, and here rain and gloomy, and both case no, no and yes. So no, play no, play yes. So this is the simple example of a decision tree. Now with the help of this decision tree you can easily classify these cases or predict the cases. So you have a new instance, let's say windy no. If it is a rainy, then definitely you are not going to play. If it is a again windy and it is gloomy, you are not going to play. So now this was an example of classification with the help of Gini index. Now similarly for case of regression we can use the change in the standard deviation to actually draw a decision tree. So how we use here the decision same level, let's say if I have a simple example over here, I'm just going to again quickly going through the another example. Let's say I have here age, and here let's say I have designation, and here whether they are supportive or not. If I take, then maybe 20, designation maybe they are IT specialist, then yes, let's say 25. So this is kind of okay. So I have to consider the continuous variable. So yeah, let's say I want to predict, just try to find out the salary. So maybe this is 20,000 per month. 25, maybe this is the accounts. They are drawing 30,000 of salary. Another case is let's say 27, and they also part of IT and drawing salary of let's say 40,000. So in case of classification, you have observed that we try to calculate the difference between the actually Gini index. So first we calculate the Gini index for your dependent variable or your target variable. There it was a level data, in the sense a classification data, categorical data. But here what we do, we use the same concept that we are considering the variance or the standard deviation. So let's say your predicted variable is salary. So how much variance is actually explained by the age or the designation. So based on that, we are trying to find out the the particular feature which will help or start the particular node of the decision tree. So in that case, you have to just calculate like this. You first calculate the salary standard deviation SD of salary and minus standard deviation of salary with respect to your designation. So how to calculate? Let's say if I take a simple example of this. So first I will calculate the standard deviation of this. So for that, maybe you are calculating your mean 20,000. Okay, so 1 extra is 0. So 20,000 plus 30,000 and 40,000. Then divided by 3. So 40, 30, 70, 90. So it is 30K. Then you just use this value to calculate the standard deviation. So how to calculate the standard deviation? Basic formula is nothing but sum of your observed, then mean square divided by number of observation. So basically what you have to do, 30,000 minus 20,000 square, 20,000 minus 30,000 square, then 30,000 minus 30,000, and again 40,000 minus 30,000. So 10,000 square and 10,000 square. So it will be, and how many observations? You have 3 observations. So it will be, the standard deviation value would be 2 into 10,000 square divided by 3. So once this is the standard deviation for your salary. Now a specific designation, I have to calculate this standard deviation. Let's say I have 2 cases of my IT, so I can easily calculate the standard deviation for this 2 IT case. So in that case, SD salary comma IT, this will be, you have to just find out the mean of this. So 20, 40, so again 30,000. So it will be again 2 into 10,000 square and divided by 2 and square root. So it will be around 10,000 square. Okay. So once you have these 2 values, now you can straight away the change in the standard deviation can easily calculate, and so that will be just negate these 2 values. So 2 by 3 and then square root into 10,000 minus this root over 10,000 square, and so it will how much? Again 10,000. This is also 10,000. 10,000 into 2 by 3 square root, and this will be again 10,000. So 10,000 root over this value. So this value actually gives you the indication of how much variance change is happening for a particular variable. So similarly, you can calculate for age, and the highest value will be determined as the node for starting the problem. So in our case, I have two nodes. So here my salary basically dependent on mostly from the calculation is that my age. So age will be starting node. So there you can create a two different. So if it is at more than 25 years and less than 20, so more than, so greater than 25, and other is less than 25. So there you have options, again designation, and based on the designation maybe IT, and this was account, here only one IT was there. So you can easily create the rules for particular prediction. So this was around 20,000 or something, or this was 30,000, 35,000. So this is the core concept, how you can use the standard deviation and your Gini index for creating regression. So this is classic example how the standard deviation change can be considered for solving a regression type of problem with the help of decision tree, and your Gini index can be useful, very much useful to solve the classification type of problems with the help of Gini index. So hope you understood the basic concept of this decision tree based prediction with the help for regression and classification. So we are not going into the deep, but these are the core concept of this kind of solution. Now last topic, that last thing I should explain, that okay, these are the couple of things that you should remember while applying this kind of models. So okay, or I just clear that thing. So in case of regression, you have to use R square, RMSE, or MSE. So mean square error or root mean square error or coefficient of determination for determining the prediction or determining the capability of the particular model. And in case of classification, you have to go for confusion matrix, which is nothing but, let's say if you have observed positive cases and negative cases. So I'm just doing this thing. So maybe in classification problem, what we did, we divided into two cases, that is 1 and 0. This is again 1 and 0. This is your actual. So these two cases, this is nothing but the true positive, and this is the true negative. And here it is false positive, and this is the false negative. So these two values actually determines how much accurately your model is predicting a particular class. Now here the false negative is that actually its case was 1, but it was falsely predicted as 0, and here The actual case was 0, but it's falsely predicted as 1. So these two cells are nothing but indicating how much error actually happening with your model. So based on these 4 values, you can derive other matrices. One is accuracy. So in that case, accuracy will be TP plus Tn divided by all these values. So TP plus FP plus Fn plus Tn. Okay, so this is the one example how you can use this confusion matrix to just determine one metric. Now another thing is there, recall and precision. So precision is nothing but how accurately you are predicting the cases of 1. Let's say this is your entire case of 1, actual 1, and this is the case where how many actual ones are predicted. So from here also you can just calculate or try to measure the impact or your model's accuracy in terms of predicting a particular case. So in that case, the formula for this recall and precision will be TP divided by TP plus Fn, and for your precision it will be TP divided by TP plus FP. And if you just calculate another matrix out of this F1, that is nothing but the harmonic mean of this recall and precision. So it will be 2 into precision into recall divided by plus recall. Now this F1 score is pretty much important, as it can be very much helpful when you in the data set you have high class imbalance or bias towards a particular class. So definitely in those cases F1 score is very much good matrix, and recall and precision and accuracy you can use in any kind of model, for any kind of model, or basically classification model, for judging the accuracy of prediction. So hope you understood how to judge the models also, and also how these 3 types of algorithm can be used to create regression model and classification model. Thank you.